Sharpening a pencil is a simple task for a person, but getting a robot to do it reliably turns out to be a much more involved and interesting engineering problem. Our robot automatically picks up an unsharpened pencil, feeds it into a sharpener, applies a downward force to sharpen it, and then replaces the sharpened pencil before repeating the process over again. We built this system on a 3 degree of freedom robotic arm provided in MECH453, making minimal modification to the base kit. With a few minor modifications, this kit was able to perform well in completing this task. To achieve full automation, we designed a 3D printed pencil holder for the robot to easily grab the pencil. This pencil holder needed to be adjustable for different pencil lengths, so we redesigned it to move freely using two end pieces instead of one rigid piece. We also designed a servo-driven pencil dispenser and a 3D printed funnel that guides the pencil into the sharpener. However, the first iteration of this holder wasn't compatible with this design, so it was redesigned to flawlessly capture the pencil from this dispenser. The funnel also needed to be redesigned to help the pencil enter the sharpener. On the left was a first iteration. This design was helpful, but the angle was not steep enough. The second iteration had a harder and sharper angle for the pencil to slide through. This led to much more success with the pencil entering properly into the sharpener. Moving into the code, the robot operates entirely in Cartesian space, using inverse kinematics and cubic polynomial trajectory generation. The workspace is defined by a sequence of waypoints and times for moving between each of these waypoints, which allows for the robot to move smoothly, pause when applying the downward force, and avoid collisions throughout the task. A major takeaway from this project was realizing that software alone would not solve this problem. Multiple iterations were tested through before achieving reliable pencil insertion, and several pencil holder designs as well as funnels were iterated through as the system evolved. Here's a video of the robot completing its task with multiple loops being completed. Thanks for watching.